Hello, my name is Fernando de Zayas, and I'll be doing the code research presentation for Ilan1.4 in MetaTrader 4. To start, the majority of the research was focused on the variable type, which stands for money management type. It's an external input variable that can be changed by anyone running the advisor and can be optimized, although it only has 3 possible values, 0, 1, and 2. Based on that value, it will determine how the amount of lots are calculated in terms of buying and selling. It gives a short description at the top, just with 0 is a direct translation of the lots, 1 with the logic in Ilan1.2, and 2 with martingale logic. When we go into the fgetLots function, then it covers the specifics of how the logic breaks for every case. On a side note, the input p type is just what type of order it is, such as buy, sell, buy limit, sell limit, etc. Now in case 0, like I said before, it's just a direct lots translation. T lots becomes lots. Oh, on a side note, you will not see the return which is T lots because there are some error handling cases here just in case something else goes wrong, but it does not actually affect this logic. In case 1, T lots is the normalized double of lots times lot exponent to the power of the number of trades up to lots digits, amount of digits. This is the logic it's using from Ilan1.2. Now in case 2, where it goes into martingale logic, it initializes last close time equals 0 and T lots equals lots. Now for every order in the history, if it's an accurate order, if the symbol and magic number match, then if the last close time is less than the order close time of the current order being selected here, then last close time becomes that order close time, and if the order profit is less than 0, T lots then becomes the normalized double of order lots times lot exponent to lots digits amount. Else it becomes T lots equals lots, same as case 0. So in this case, we'd require the profit to be negative in order to see any change in how the formula would work in comparison to case 0. From here on, I'll be working on testing those out with different inputs. They'll be used on the same history time frame from July 1st, 2017 to June 30th, 2018. The spread will be 20, the time period will be M1. The main values that will change are slip, pip step, and take profit, although the one we are specifically testing for is type, where we will be doing one test on 0, 1, and 2 optimized and another unoptimized. The original optimized result used case 1, so that has the best result. Now case 0, where we're using the lots and it is unoptimized, meaning we have the basic slip, pip step, and take profit as the results given by, as the default inputs set by the author. Up until just before it closes, you can see it's slightly above, it's at a slight profit, and then just as it closes, it goes to a 75% loss. Looking at the history, you can see that the only reason this happens is because it's being forced to close at that point, and all of the current open orders are at a very low profit. just by looking at the variables that we are checking, this is saying that we do not want lots to be used directly without any changes. And the author variable and the default author variables for slip, pip step, and take profit don't seem to be helping much either. Now in case 0, where lots is optimized, it goes to a slightly higher profit before it crashes down when it's forced to close. And even then it goes lower, so you lose a bit more than 76% total. For here we're using the optimized values of slip equals 2 and take profit equals 6. Next we're going into the case 1 where we're using Ilan1.2 logic. First is the unoptimized. It's going to about a 17% profit, 15 to 17% profit just before it crashes. So we're doing a lot better up until close, at which point it kind of dies out. So just in terms of profits, going with the formula of lots times mathpal lot exponent number of trades to lots digits seems to be giving a better profit before closing. So manipulating the time of closing might help. Now, when it is optimized, it closes successfully at a higher profit. Around the 22% profit in this case. Now I move on to case 2, which is the simplified martingale logic. It's practically the same as case 0, which is a direct lots translation. So it's slightly above the base 10,000 up until closing, at which it drops to more than or just about a 75% loss. And in the case where we use martingale as optimized, it's pretty much the same. It goes a little bit higher before the crash, and it goes a little bit lower after the crash. Or more specifically, when it's closed and it has to sell at a negative profit. For my conclusions involving the optimization variables and the other constant settings, raising the amount of lots to a power seems to scale better for profits over time than taking the lots directly or multiplying them directly. This still requires modifying the optimized inputs, as those further raised a profit and even left it a bit of a positive profit before closing was involved. The default values had a slight profit before crashing, just before close. My suggestions for working with this are to work with other variables after the optimized ones are stabilized, while ignoring the early closing variables, since they just stop profit loss from going too far. What I mean by this is that some variables, if they're set to true or false, or some are allowed to set values so that if the profit goes too low, it'll automatically close and try to recover, but from there it's pretty much a safety net that we're already so far below a profit that it doesn't really matter. And the next part is to move some sections between layers, such as inside an if layer to inside a for layer. Some sets of branches have odd logic that seems like they should be skipping a step, but since they're at the same level as the one that's skipping them, it still goes through others that it shouldn't. So that's going to be part of the code revision to see if doing so will improve the performance. That's about it for the code research. Thank you for your time.